Delighted to introduce Matthew van Wingerden and Antonio de Cejas, who will be teaching us about architecturing AI and analytics for global scale. Team, over to you, and see you for the Q&A section at the end. The stage is yours.
Thanks a lot, Dario, and thanks everybody for taking the time to discuss this topic with us today. I think it's a particularly challenging one as we look to build out AI at scale. I know a lot of the previous conversations have talked about resourcing and doing the upfront analytics and preparing your data, but it's very difficult to actually get your AI itself, right, the analytical models to scale. Before we get into a lot of detail about it, though, I'd love to just use a little bit of an analogy and experience that I'm sure we all face on a regular basis, which is streaming a video or a movie when the bandwidth on our internet connection goes down. And this happens all the time. And can you imagine how frustrating it would be if every time there was a little bit of break in our network connectivity, the movie would just stop? It would be a terrible experience. And of course, Netflix and Hulu and Amazon and others, they figured this out. And so they figured out how to deliver a roughly consistent customer experience, which is an uninterrupted video, across inconsistent conditions or inconsistent supply of internet bandwidth by throttling the resolution. And sometimes it's pretty noticeable, but to be honest, I much prefer that than having the whole thing stop. And so that's kind of what we're talking about today. But before we get into how that relates, let's just talk about what our goal is when we're talking about AI at scale. And so the goal here is to have the effectiveness of the personal approach, which has been used for as long as any of us can remember in the pharma industry, because it is so effective, because you have those personal relationships, you have direct knowledge of what the customer needs, and you can build a communication plan for each individual customer. But taking that effectiveness and doing it more at scale in a way that is more effective across different channels, and quite frankly, more cost efficient, and just even has visibility into channels that are now non-personal by nature. And so that's what we're going to be talking about today, is how to design something on the right-hand side. But keeping in mind the entire time that there are certain challenges. So one, as I was saying before, we really want to maintain nuance. And quite often, I think people see it as a trade-off between nuance, where you can have that great customer relationship, or scale, right, that you can have one or the other. And obviously, that's not what we want to have. We want to have both. And the second piece is just acknowledging that our inputs are not the same everywhere we go, right? The data availability, the data landscape in the pharma industry is not monolithic. I think we're all very familiar with that. So putting it all together, what we're trying to do is accomplish the same thing that the streaming providers are doing, which is giving consistent experience. In this case, the experience, quote unquote, is a consistent commercial optimization approach, but doing it when there's inconsistent data, there's different channels that may be available for different brands or different therapeutic areas in different markets, and so on. So with that in mind, let's talk a little bit about how we So the three categories that we think about. First is modularity, where we avoid having any black box analytical model or data science model. And the point here is, the problem with the black box is if anything goes wrong inside the black box, the whole thing is broken and you have to throw it out and start over. So we need to give more transparency and more control within the analytical or the AI system, so that we can directly intervene if there's one piece of data that's missing, which will happen all the time. Second piece is visibility, which is just about, okay, once you've designed your system for modularity, knowing which modules you can turn on in different places, where you have to do data transformations to make it work, and just knowing where you have to enable last mile delivery, which is the third topic, about empowering local teams when there are specific circumstances that require either tweaking the outputs or actually developing, in some cases, custom models, knowing how to empower that. I'll be covering the first topic, and Toni will be covering the second two. So when we talk about modularity, there's two levels of modularity. One is the overall optimization. And you can see an example of that on the right-hand side, where a lot of times we talk about next best engagement. And sometimes we talk about this as one chunk, right? Like we're solving next best engagement, but really we're solving a number of different problems, which is next best message, next best channel, next best customer, because sometimes we have to prioritize between customers for channels that are limited in resource, and also the best timing. And the point here is the more we can be very clear about the individual elements of the optimization of the customer experience, we can solve them individually, and then we have a better chance of them being recyclable from market to market in different data landscapes. Or if something goes wrong, that we can just switch out a small piece of it and we don't have to throw away the entire system. And the second piece is a little bit more detailed. It's even within one of these, next best customer, next best message, whatever, how do we actually set up our analytics to be more scalable? And we won't go into a lot of detail about the analytics itself. Happy to have follow-up discussions with anybody who's interested. What we're trying to talk about here is a little bit of the overall solution design, right? Maybe somebody who's more from the business partner side, not necessarily detailed data science discussion. So let's talk about the higher level of modularity of what does that actually look like. So the first piece is, just designing, as I was saying, these different pieces. I won't belabor that point too much. The second part is designing the right level of accuracy or the right level of complexity in the solution for each of these questions. So for each of these individual pieces about channel preference, timing preference, and so on, we can either have a very complex machine learning model because maybe we have a lot of data and it's actually worth it, or we can have something that's a little bit more simple, some more traditional analytics, or in some cases, we just have to have human input. And this is common. I'll use the example in the China market, where the sales data is very slow. It's very aggregated at the large hospital level. And so quite often there's just human intel that's needed. And that's fine. We can do that. It doesn't have to break the system. Now, the last piece is just evaluating the trade-offs, because while the data availability may actually allow us to do some complex machine learning, it doesn't necessarily mean that it's always worth it, right? There are some markets where you technically may have some more data, but I think we all know there's just a little bit of a question that we always have to ask ourselves of, is it worth spending the money on a very complex data science project to do something specific for this market when maybe there's not the return or it's not a higher priority brand. So just as an example, and intentionally showing a bit of a complex slide here, but the point is, in this little toy example where we are, in this case, solving for a specific set of circumstances of which customers we want to engage in which channel. And in this little example, there's only 2 customers and 3 channels, which obviously is oversimplified. But the point of this is, there are different inputs, right? We have the priority of the HCP, we have the priority of the channel, the propensity to engage in the channel, or the likelihood that they will engage in the channel, and all of these come together. And so we can imagine that each of these individual columns, each of these individual data points can be supplied by different means, either machine learning or human input, and even different vendors or different teams doing it. As Paul and Michael were talking about in the previous section, a lot of enterprise customers that we see are building out complex multi-source strategies, right? Where there's one vendor doing one piece, another vendor doing another piece. You go to a new market, that may change a little bit, as long as you define the high-level structure in a very modular way that works. And the last piece, which I won't belabor here, is just the details of one particular model, which is our sales change detection, which is just detecting significant deviations in sales model. And the important part here is you can see there's multiple actual analytical models under the hood, and they have different data requirements. And basically the way it works is our system goes through and it checks automatically if you've got 2 years of historical data. We turn on the seasonality and trend adjustment. If you don't, we don't turn that on. Right? If you've got daily data, like you would have for purchase order data, then we can actually see if there's an unusual gap in purchase orders. If you don't have daily data or weekly data, if you don't have daily data, we take that out. And it's all just kind of managed automatically. And the same thing with the last piece there, which is if you have weekly or monthly volume data, we can see the statistical variation. And the point here is not to get into what specific model we're using. The point is to have the expectation when we're building something for a global scale or even regional scale, that even the individual analytical pieces have to be built with an eye towards what data is going to be available in different situations. We can still have the same output overall, which is, hey, this HCP or this account or this brick has an unusual change in sales data. The way we get there can be a bit more flexible. But as long as we have the same output, it plugs into that modularity that I was talking about before. Toni, I'll turn it over to you.
Thank you, Matthew. So I will cover now the second aspect to consider when designing and optimization of your commercial operations at scale and with flexibility, which is basically know what you have, know before you go or know before you design the system. So basically, the advice is very simple. So analyze everything in depth before you start designing everything. And analyzing everything in depth means basically two aspects. First one is your technical and data ecosystem. And second, all your business rules and imperatives coming from regulations or differences in data sets in your different markets. So once you analyze all these ecosystem, you will end up with two types of differences across your landscape, most likely. A first set of solvable inconsistencies or differences, and a second set that are permanent. And there is nothing to do about them because they are coming from business strategies, different tactics, different channels or regulations. So nothing to do about them, but you still have to adapt to these permanent inconsistencies. Next, please. So this is an example of solvable inconsistencies that we found in an actual anonymized project. Actually, this is always the first step that we execute when we start a project, this data readiness assessment, analyzing all these ecosystem that I mentioned before. And these are two examples of inconsistencies that we found in different areas. So the example one is coming from the HCP specialty data, and the root cause is inconsistent master data management. So if you can read the table below, it's a bit small, but you can see that the same specialties have different names across different countries. And that will make it more difficult when you want to apply AI on top of this, or even when you want to apply business intelligence, traditional business intelligence. The example two on the right-hand side is coming from interaction data. And in this case, it's an inconsistent use of data models and systems. This particular analysis was conducted during the COVID pandemic, right? So if you look at the face-to-face row, it has high numbers. And that's in theory not possible during the pandemic. Or if you look, for instance, at how country 5 is reporting remote interactions, they are reporting them in a completely different way to the rest of the countries, right? So even this particular customer, even having same data model, same tools, you have differences in the way they are used, right? Next, please. So these were just two examples, two typical examples that we find when we are implementing an AI program. And here you have some more with recommended actions to perform to resolve all these inconsistencies. I will not go through in detail through all these, but well, on the left-hand side, you see some of these examples. For instance, having the same data set coming from different countries in different formats is not efficient. So the recommendation obviously is to harmonize, to consolidate that data set. That will make it much easier to import it, to ingest it into the system and be able to provide conclusions from it way earlier. Same happens with HCP profiles, as we saw before, different ways to name the same specialty. That complicates things, or having standard values across important fields. So these are things that you will find when you complete this readiness assessment. However, there are workarounds and ways to resolve this. So if you move to the next, please. So our recommended approach to resolve these inconsistencies is first always to start with the data readiness assessment that I mentioned. That's, of course, the first step to know exactly what you have, your landscape, to understand all these different uses or inconsistencies around your company. When all that is clear, when you know what is consistent, what is common, and what is different, our recommendation is to build a flexible ETL and data ingestion process. And how to do this? So even if different countries and different brands within those countries are using the same system in different ways, always there are like similar patterns in the use of those systems. So for instance, you will find most likely 2 or 3 different ways across your ecosystem to store rep to account alignment information. Or you will find most likely 2 ways to store interaction targets. So after all our years implementing projects, this kind of project, these are the scenarios that we find consistently, right? So then, instead of developing a new wheel or reinventing the wheel every time you have a difference on all these data processes, what we recommend is to build a flexible ETL that considers, that includes these scenarios that are most common in your ecosystem, and then without code, point the ETL to the scenario that you have for each brand and country. So basically, implement these common scenarios and just through parameters, no code, point the ETL to what you have for each specific country and brand. That will save a lot of work and will avoid having to reinvent the wheel all the time. However, this applies only to these common patterns. So if you find a country and brand that aligns to one of these common uses of your data model or systems, there will always be exceptions and one-off scenarios, right? Things that are very specific to a particular brand and country, and you're completely sure that you will not find anymore, right? In this case, obviously, the recommendation is to develop a custom solution to cope with that, because it doesn't make sense to add that new scenario as a standard feature in your standard ETL. Next, please. And these are some examples of the ETL process that we developed at Aktana that uses this philosophy. And these are some examples of these common patterns or common ways to do things in your CRM. For instance, when it comes to storing rep to account alignment scenarios. So most commonly we find two. Either that information is stored in the MCCP objects or it's stored in the territory management objects, right? So instead of having to, again and again, for every new implementation, develop a new ETL, we have the two scenarios that are most common already present in our standard ETL, and through a parameter, we just select the scenario that we have in each case, right? Then through some parameters, we fine-tune the connection to make sure that we are pulling the data correctly, and that's it. But we don't have to write new code all the time. And this accelerates the implementations and makes them more cost-effective. And you have more examples here. So you have more examples for account segmentation. That's another typical case. For interaction targets and scenarios, you would have some examples for uses of different medical event systems or differences in the sales data formats and providers. And basically, through managing all this complexity through this flexible ETL, you will end with a harmonized data model where you can base your AI-driven optimization program, because that data model will be always the same and stable, right? So some comments to add here is that an AI-driven commercial optimization program doesn't need an end-to-end master data management program. So you don't need to review everything from R&D to commercials. It's not needed. So you just have to focus on the data objects that are needed by the AI models. And they are not that many, to be honest. And another thing to mention, and I loved one quote from Paul. So he used the crawl, walk, and run philosophy in Novartis. So when they started in Novartis, their data landscape was not perfect at all. But they started crawling and they started doing with it everything they could. And in time, they improved. They resolved all the quality issues, inconsistencies, and then they were in a better position to move to the walk and run use cases. So perfection doesn't exist, so don't wait for it. And our recommendation is to start with the crawl phase. Next, please. And finally, the last topic to consider to design in a flexible way your commercial optimization program is this last mile delivery. So everybody knows that the local teams have a lot of knowledge about their customers, and they will always want to fine-tune suggestions or fine-tune the configuration. And that's actually very good, because we have to leverage all that information that they have acquired during years, right? So next, please. These are some examples of differences that we have across different countries. So for instance, if we look at the US, email is the channel that is most used by far. Germany is fax, and China is WeChat, right? So next, please. And here we have similar examples from different business rules and different regulations that we have in different countries that will force us to adapt the configuration of the system. So if you remember, when we classified the inconsistencies in solvable and permanent, these are examples of permanent inconsistencies. So we cannot do anything about it. So these are local regulations in each country, and we have to adapt our systems to cope with these customizations. So then the key question is, next please, Matthew. How can we cope with local differences and global efficiencies at the same time, right? So our recommendation is to design your system's configuration in a hierarchical way with different layers of settings. In this example, we are recommending 3 levels, but we could add one more for brands. I will discuss it at the end of the slides. But if we stick to this example, we have 3 levels. So we would have a global level where we could place all the configurations that are common across all countries and brands. Again, using another quote from Paul, in the case of Novartis, 70 or 80% of the use cases are common across all countries and brands, right? So that information, that configuration could be placed there at the top. And all the regions and all the countries hanging from that global configuration will inherit that configuration, so that you don't have to develop those configurations again and again for every new project. You place them up there and then you can inherit them, right? But what happens if a region has something different versus the global use cases? Then if that is something common to all Europe or all Asia Pacific or I don't know, Latin America or whatever, you could place that difference at the regional level, and that would override whatever comes from global. So if one of these regions has a difference versus the global configuration, you could there change that setting. That configuration would be applicable to just the region where you have deployed that configuration, and all the other regions would still align to the global one, right? And we would use exactly the same logic for the country level configurations. So following the examples that we saw before, if in the UK there is a maximum of 3 unsolicited calls per year, we could place that rule, that constraint that is completely specific to the UK, we could put it down there at the country level, right? All the other countries would still inherit the standard or the normal let's say a scenario where these interactions are not limited, but the UK would have a different case, right? And with this kind of system, we can combine global efficiency with implementing the differences, wherever they are in your data landscape. And that's it from me. You're on mute, Matthew.
Good time to do that, huh? So just to summarize then, we talked about these 3 steps to maintain that consistent movie watching experience, or the consistent AI optimization, regardless of the underlying data infrastructure and available channels. And first is design for modularity. Again, if you design it all as one piece and anything goes wrong, then the whole thing breaks. So that's obviously not the right approach. Second is to really just evaluate where you have the same data, where you have the same messaging strategies, and where you do have to do something different. And as Toni was saying, some of this is solvable, Some of it is permanent, and for the permanent things, then figuring out how you empower your local teams to do the last mile delivery. Not so they have to rebuild the entire thing, but so they can just take that last piece, which is not the 70 or 80% that's common, and just tweak the remaining 20 or 30% that's specific to them. And that's it. Thanks.
Any questions, comments?
Right, so I'm back, and I can only say what a great session, so guys. And we received a couple of interesting questions, and the first one was raised to Matthew, which is how do I ensure my specific brand strategy is reflected by out-of-the-box AI modules?
Yeah, it's a very important question, and it goes back to what we started out of making sure that you can maintain the nuance even as you try to approach scale. And there's two ways I think about it, basically upstream customization and downstream customization. So upstream is making sure that you treat your data in a different way and you actually build your analytics in a different way for each brand. That can be effective, but to be honest, it's very expensive and it's difficult to get right. What I've seen much more effective is downstream, where we're setting constraints on it. It's kind of like Toni was saying that no matter what happens, I'm going to limit my output to 3 visits per year or something like that, some frequency that's limited by a certain market, or there's certain messages that I'm not allowed to use in a market. And it could be very specific around a marketing event. So if you have a brand strategy that says, hey, we're going to get all of our oncologists to attend the big ASCO conference in a certain month, and I'm going to allow the AI to do some of the optimization around the messaging for the invites and the timing of sending those invites, but I'm going to constrain it to messages related to the ASCO conference and a certain time window in front of that conference. Then you can kind of get a bit of a balance where you're taking what you know, which is your brand strategy, and then you're allowing AI to fill in some of the gaps because you're setting constraints around what it can do.
Fantastic. Question to Antonio. How do you maintain control over how the AI is used by your team?
Well, in several ways. So one of the internal tools of the system is called omnichannel control center, and it allows us to do a number of things. So, for instance, we can enable and disable modules. So, as Matthew discussed during his presentation, so the next best action process is split in a number of steps. So first we are analyzing what is the best channel for the next interaction or the next suggestion, then the next piece of content, best account, etc. Each of these decisions is coming from a different module, right? And this control center allows us to enable and disable modules and also import modules coming from customers. So if a customer has a different way to prioritize accounts or to decide the channels and that they want to recommend, they can disable our modules and import theirs. So this is one way. A second way to control the behavior of AI is through simulation functionalities. So this same omnichannel control center has simulation functionalities so that when the system is completely configured, we can play with it. So we can simulate the suggestions and insights that it will generate in the near future, and then compare what the system is going to trigger, what it's going to suggest, with the marketing objectives. So that, for instance, if our marketing hypothesis is that we want to focus on a specific segment for a specific brand and use a specific message, we can configure all the system, simulate the outputs, compare versus our objective, versus that tactic, and then promote that configuration to production to start triggering suggestions and insights to achieve their objective. There are more things like engagement reports, etc. But overall, yeah, we have quite a few functionalities to control how AI is applied.
Thanks a lot, Toni. So, gentlemen, Matthew and Toni, thank you both. We will see everyone in a minute for our last session of the day. It was a great discussion and looking forward to the closing session. Take very good care, gentlemen.
Thank
Thanks
you.
a lot.